It is now time to move on to section 4.5, first order linear equations. Let's define what that is. A first order differential equation is linear if it can be written in the form a of x times y prime plus b of x times y is equal to c of x, where ax, bx, and cx are just something in terms of x. That's all fine and good, but that form doesn't really help us a whole lot. So I actually want these in standard form. And the standard form is going to be just 1 y prime plus pxy is equal to qx. It is very important we know how to write it into that form here. And then whenever I have it into that form, being able to tell what p of x and q of x are, because those are going to help us solve it for the y. So before I learn how to solve them, I want us to practice putting them into standard form. Okay, so that's what I want to do on all of these. Example 1, we are going to rewrite all of them into standard form and then state what p of x and q of x are. So 1a is y prime equals 3x minus 4y. So for standard form, notice I want every y on the left side. So let's do that first. Make sure every y term is on the left side. I have a y term over here, so add it so that it's on the left side. So that means I'm going to have y prime plus 4y is equal to 3x. That's my first step. Then I want to make sure in front of y prime, I just have a 1, which luckily on this one, I do. So that's it. I'm good right here. This is the standard form. Every y is on the left side, and there's a 1 in front of y prime. So that's it. So now I want to know how to find p of x and q of x. P of x is going to be what's in front of the y. Q of x is what's on the right side. So p of x in front of the y is a 4. So p of x is just 4. And then q of x, again, is what's on the right side. On the right side, I just have 3x. So that's it. Part B is 3xy prime over 4y minus 3 equals 2. Notice it says on here, for those of you who have it, assume x is positive. When we get into solving them, I'm going to explain why I need that there, like I have it here and I have it there too. I'll explain why whenever we get there, but for now, just know that it doesn't change what I do. Okay, it doesn't change the process. Okay, so this one looks really gross because I have stuff divided by stuff. I don't like that. So let's times it by 4y minus 3 to get rid of the fraction. That would cancel it out over here. On the left side, that leaves us with 3xy prime equals 2 times 4y is 8y, 2 times the negative 3 is negative 6. Way better, right? Now I want to move every y to the left side, so that gives me 3xy prime minus 8y equals negative 6. But I can't stop quite yet because in front of the y prime, I just want a 1. I have 3x, so I don't really like that. So we're going to divide everything by 3x to get rid of that here. So that's going to give me y prime minus divide by 3x, gives me 8 over 3xy equals negative 6 over 3x. Negative 6 over 3 is negative 2, so that's going to be negative 2 over x. Now I can stop because every y is over here, which is good, and there's a 1 out front, which is good. Px is what's in front of the y, so that's negative 8 over 3x. And the q of x is what's on the right side, so negative 2 over x. Lastly, example letter C, the third one, is y equals 3y prime minus 4x squared plus 5. So again, I want every y on the left side. I have a y there, so move it over. That's going to be negative 3y prime plus y equals negative 4x squared plus 5. And then again, I want a 1 right here, so divide everything by a -3 so that I have that. That's going to give me y prime. That's going to be minus 1/3 y equals, that would be positive 4/3 x squared minus 5/3. So the p of x is what's in front of y, that's negative 1/3, and the q of x is what's on the right side, so 4/3 x squared minus 5/3. So if it doesn't make sense how to put it into standard form or how to find what p of x and q of x are, let me know. I'll help you with that. But that's a very important first step that I need to know in order to solve these for y. So now let's actually learn how to solve these for the y, okay? So once I'm in standard form, which is what I want, once I'm in standard form, which again, I'm just rewriting it for the purposes of what I'm fixing to do. Standard form is y prime plus p of x y equals q of x. How I'm going to solve this for y is I'm going to use something called an integrating factor. And what that is, I'm going to use the Greek letter mu, M-U, mu, which looks like a cursive U. Mu is going to be equal to e to the power of the integral of px dx. You're probably thinking, why, when it doesn't look very hard, would I make it look even worse, right? This is going to save our lives. Because what I'm going to do is I'm going to multiply everything on here by that mu, okay? So this is going to end up being e to the integral px dx times y prime plus e to the integral px dx px y equals, I didn't leave myself enough room at all. I'm going to rewrite it really quick so I have more room. Mu equals e to the integral px dx. Times it by every term equals e to the integral px dx times q of x. Like I said, you probably think this looks worse. Why do I want this, right? Well, let's think about how this kind of looks, okay? So over here I have e to all of this stuff times y prime. Whereas with this term I have e raised to all of that stuff times p of x times just plain y. Let's look at this right here and think about it really quickly. If I took the derivative of this mu over here, right? We know e stays e, so then it would just be e to that to that stuff, right? But then by the chain rule, I need to times that by the derivative of the top part up here. Well, the derivative of this is like taking the derivative of an derivative, which cancels out. So if I was taking the derivative, it would be e to that stuff times just p of x, which is exactly what this is right here. So notice what I have on the left side is mu times y prime plus mu prime times y. That's the product rule. That is exactly the product rule. So on this left side, what this actually is the derivative of mu times y. So what this means is to solve it for the y, all I've got to do is take the antiderivative of both sides, which is going to just leave me with this is the mu, right? Mu times y equals whatever that is. So to solve it for the y, just divide by mu. So even though it looks worse, it's going to help us out a lot and make these things not very hard. Okay. So let's do some examples. Example number 2, because example 1 was writing it in standard form, right? So example 2. Find the general solution for the differential equation xy prime plus 3y equals 4x squared minus 3x. Again, notice on the note sheet for everybody who has it that x must be positive. I'm going to show you why when I get there, okay? But again, this doesn't change anything. I'm just going to show you why I've got to have that here. Okay, so first things first, is this in standard form? No, because I don't have just a 1 right here, right? So to make this a 1, divide everything by x. So this is going to become y prime plus 3 over xy. Divide this by x, you just get 4x. Divide this by x, you get minus 3. So now I've got to find what the mu is. So remember, mu is e to the integral of px dx. Px here, remember that's what's in front of the y, so that's going to be 3 over x. 3 over x dx. If I do that out, notice that is the natural log, and the natural log is why I have this. Because normally I would write it as 3 natural log absolute value of x. But by having this, I don't have to. I can just write it as the natural log of x. That's why. Okay, let's simplify this because that kind of looks bad. Remember, if there's a number in front of a logarithm, I can bring it up as the power. So that means I'm going to have e to the natural log of x cubed. But remember, the natural log is log base e. So this is e raised to log base e. They cancel out. And I'm left with just x cubed. So my mu is x cubed. And I want to multiply everything by x cubed. Okay? And remember, like I said, what that does is it turns the left side into mu, which we just said was x cubed, times y prime. So now I can write it just like that. If you don't believe me, on the first one here, I'll work it out to show you if I times everything by x cubed, that'd be x cubed y prime. X cubed times 3 divided by x would be 3x squared, because I started with x cubed divided by x is x squared. So 3x squared y equals, and then do x cubed times all of that, 4x to the 4th minus 3x cubed. Notice here, x cubed times y prime, this is x cubed times the derivative of the y. And then this side is 3x squared times y. Well, see here, 3x squared is the derivative of x cubed, right? So this is mu times y prime plus mu prime times y, which is the product rule, which means it's just mu y, that whole thing prime. And we said our mu was x cubed times y prime equals this. Haven't changed anything over here yet. That doesn't make sense, let me know. So now we can take the antiderivative to cancel out this prime, right? So over here I just get x cubed y equals antiderivative of this, add 1 to the power, right? 4x to the 5th over 5 minus 3x to the 4th over 4. Don't forget plus c, still need it. So to solve this for a y, just divide by x cubed. So y equals, divide that by x cubed gives me x squared. So 4x squared over 5 minus, divide this by x cubed just gives me an x. C over x cubed. I can't just leave this as a c because now it's a constant divided by something that is not a constant. So I've got to write it just like that. So this, even though maybe understanding the concept here, maybe that's a little hard, but if you see, the process was quick. These actually aren't very hard at all because it turns into something that's not very hard. Let's try example number 3. Find the general solution for the differential equation. The quantity x minus 2 times y prime plus y equals 3x squared plus 2x. And again, it says assume x is greater than 2. That's not going to change my stuff. That's just going to make sure that the logarithm is always positive. All that does. Okay, this is not in standard form yet because I don't have just a 1 out front. So put it into standard form. Y prime plus 1 over x minus 2y equals, and then just put all that over x minus 2. I am now in standard form, so I'm happy. So now I can find the mu, which is e to the integral px dx. Well, px is 1 over x minus 2 because that's what's in front of y. Integral of that's just the natural log. Again, the reason I have x is greater than 2 is so that I can just leave this as x minus 2. And then, like I said, e to the natural log cancels out, so I'm left with just x minus 2. So what this means is on the left side, it's going to now become, remember, it's always mu y prime. Mu is x minus 2 times y prime equals, and then times the right side by x minus 2. Doing that's going to cancel them out, which leaves me with just 3x squared plus 2x. This isn't bad because now I can just take the antiderivative of both sides. That's going to cancel out with the prime, so it's just x minus 2 times y. Antiderivative of 3x squared is x cubed. Antiderivative of 2x is x squared. Don't forget plus c. So to solve this for the y, just divide by x minus 2. There we go. Easy enough, right? Didn't even take a whole board. Last class it took 2 whole boards, right? This one isn't nearly as bad. Example number 4 is actually an initial value problem, which means we're going to have to actually solve it for C. This one is y prime plus 3y equals 2x minus 1, where y of 0 is equal to 3. So again, this point just means we're going to have to actually solve it for C. First things first, am I in standard form? I am, because every y is over here, and I only have a 1 right there, which means I can just go straight into finding mu. E to the integral px dx. What's in front of the y now is a 3, so that's integral of 3 dx. Integral of 3 is 3x, so e to the 3x, which we can't simplify any other way. So that's it. So remember, our left side is always mu times y prime. We said mu was e to the 3x times y prime equals e to the 3x times each term right here. So that's going to be 2x e to the 3x minus e to the 3x. Take the antiderivative here. That's going to cancel out, just leaving me with e to the 3x plus y, or times y, by mistake. Equals. This is going to take a little bit more work because this is a product, right? So I'm going to have to do this by parts. Remember, by parts, we need to pick a u and a dv. I always want it to like break down, right? So I'm going to pick u to be 2x because then the du is just 2 dx. And then dv, e to the 3x, antiderivative of that would be 1/3 e to the 3x, because in order to have e to the 3x, I must have had a 3 there, but I don't have a 3, so I put a 1/3 out front. So this is going to be uv, which is 2/3 x e to the 3x minus the integral v du. So that's going to be 2/3 e to the 3x dx. Luckily, this one I can just do outright. Once again, just like what happened here, I must have had a 3 out front, but I don't, so I'm going to put a 1/3 e to the 3x. Of course, always put plus c. Now I've got to do this part, but it's the same one I just did. It's 1/3 e to the 3x, which is going to make this 2/9. So e to the 3xy equals 2/3 x to the 3x. Again, this is going to be 2/9 because I had to bring down a 1/3. So minus 2/9 e to the 3x minus 1/3 e to the 3x plus c. I have like terms here, so if I want to, I can make that into 1. The common denominator must be a 3 or a 9, so multiply by 3. E to the 3xy equals 2/3 x e to the 3x. Negative 2 minus 3 is negative 5, so minus 5/9 e to the 3x plus c. But I want to solve this for y, which means I need to divide it now by e to the 3x. Doing that on my first term cancels it out, so I just have 2/3 x. Same thing here, it cancels that out, minus 5/9 plus, but then with c, I'm going to have divided by e to the 3x. This one, the only reason it seems like a harder one is because of this guy right here. I've got to do it by parts, which makes it seem a little harder. But the only new thing here is going from here to here. Everything else is stuff we have already done in this class. Can't stop yet though, because I have a point, which means I've got to solve it for c. Plug 0 in for x, 3 in for the y. 3 equals 2/3 times 0 minus 5/9 plus c over e to the 0. This term becomes 0 here, so 3 equals negative 5/9. E to the 0 is 1, c over 1 is just c. So I just have to add 5/9. 3 plus 5/9. Need to put it over 9. 27 plus 5 is 32. So c is 32 over 9. So what I get is y equals 2/3 x minus 5/9 plus 32 over 9 e to the 3x. If any of that does not make sense, please don't be afraid to reach out. I'll help you out. One more example is example number 5. There we go. Y prime minus 2y equals 4x plus 3, where y of 0 equals negative 2. Again, this is already in standard form, so I'm good to go ahead and find my mu. E integral px dx. P of x is negative 2, so this is going to be e integral negative 2 dx, which is going to be e to the negative 2x, which if you want, you could write it as 1 over e to the 2x, or leave it like this. Doesn't really matter. Actually, whenever we multiply on the right side, it may look better having a negative 2x, so just leave it like that. It doesn't matter though. So again, the good thing about mu is my left side is now going to be mu e to the negative 2x times y prime. But now I've got to times everything over here by the mu. So 4x e negative 2x plus 3e negative 2x. Integrate both sides to cancel it out over here. I just get e negative 2x y. Do the same thing here. I've got to do it by parts because it's 4x times e. So I've got to do it by parts. U would be my 4x, so du would be 4, which would make dv have to be e to the negative 2x, which would make v negative 1/2 e to the negative 2x. Again, because out front I would need a negative 2. I don't have it, so I have to divide it by a -2 instead. So that's going to be, I'm going to bring it down a little bit. UV, so negative, or 4 times a -1/2 is a -2 x e to the -2x minus the integral v du. -1/2 times 4 is -2, so plus 2 e to the -2x dx. And then again, antiderivative of this part, I can just do that. Again, because I need a -2 out front, I don't have it, so divide it. You get -3/2 e -2x plus c. Still got to do this. Luckily, what's really nice about this is, like I always say, I would need a -2. Well, I already have +2, so all I've got to do is make it a negative. I don't have to put a 1/2 there. Again, because I would need a 2, I already have one there, so I just make it minus e to the -2x dx minus 3/2 e to the -2x plus c. Like terms over here, so do -1 minus 3/2 is -5/2. So to solve it for the y, I just need to divide by e to the -2x. That's going to cancel it out here, leaving me with just -2x. Cancel it out there, leaving me with just -5/2. Dividing by e to the -2x is like saying times e to the 2x. Wish I could stop, but I can't. I have a point, which means I've got to solve it for c. So plug 0 in for x, -2 in for y. -2 equals -2 times 0 minus 5/2 plus c e to the 0. That's going to give me 0. This is going to be 1, which means it's just 1c plus c. Add 5/2, -2/1 plus 5/2. I need a 2, so times 2 times 2. -4 plus 5 is 1, so that's 1/2 is my c. So put 1/2 in there for c, and we're good. Once again, if any of that doesn't make sense, please just let me know.